Well, hey there, everybody. It's your boy, Mr. Perry. And here we are, a brand new unit, Unit 4, starting with Lesson 1. And we are getting into iteration, we are getting into loops, and we're going to be starting with Lesson 1, while loops. So let's go ahead and hop into it. So first off, iteration, I'm sure you remember from computer science principles. It's just a fancy name for loops or repeating a section of code. So for instance, we've got some iteration happening down here. It says int bottles equals 99, and then while bottles are greater than 0, go ahead and print however many bottles of root beer on the wall, and then bottles minus equals 1, and then this keeps going and this keeps going, and then way down here outside of the curly braces it says, oh no, we're all out of root beer. So this is what iteration looks like. This is a while loop. And there you go. As far as our terminology is concerned, you have what are called definite loops, and then you have what are called indefinite loops. And a definite loop is what we would call a counter-controlled loop, which means it repeats a specific number of times. So if I was going to do a counter-controlled while loop, I would need to create a variable, and in this case I'm calling it count. And it says while count is greater than 0, go ahead and print count, and then count goes down by 1. And then when it gets to 0, it's going to print blast off. So this is a definite loop because we know how many times this is going to loop. We know it's going to loop 5 times. Just like our bottles example from the previous one was also a definite loop because we're starting with 99 and we're going to count down all the way down to 0. And so again, we know what the starting point is. We know what the end point is. It's a definite loop. Now, an indefinite loop is different. A lot of times indefinite loops are input controlled loops. So basically, we're asking the user to type something and that is going to control the loop. So it might loop 0 times, or it might loop 100 or hundreds of times. And again, that's an indefinite loop. So down here, string answer equals input.next line. So there must have been a question up here before then. And it says while not answer dot equals no, go ahead and print hello there, would you like to keep going? And then answer equals input dot next line. So we're asking them again, if they print yes, it's going to go ahead and do this, and they can print yes 100 times, 1,000 times if they want to, or they can just print no. And if the answer equals no, then it's just going to say thanks for playing. We don't loop that at all. So that would be an indefinite loop. And again, indefinite loops are more commonly what we call input controlled loops. All right. Now, the main thing to get out of this first lesson in loops is that all loops in Java need to have 3 things. They need to have a starting point. So you have to tell them where to begin. They need to have an end point. The loop does need to stop at some, point in the program. And then finally, they need to have a way to move forward. So they need to know where to start. They need to know where to end, and they need to have a way to move forward from the starting point to the ending point. So those 3 components are what all loops in Java need in order to make happen. So we'll go ahead and look at an example here. Steps to writing a loop. Step 1, we need to declare and initialize a loop control variable. So this is our place to start, right? So int count equals 5. We now have on our trace table over here our variable count. It is set to 5. And now we need to go ahead and give it an endpoint. So it says while count is greater than 0. So now when count equals 0, that's our endpoint. So as long as count is greater than 0, then everything in between our curly braces will execute. All right. So we're going to print 5, and then count goes down. So step 2 is to test the loop variable using a Boolean condition. Again, your loop variable is count. You need to test it using a Boolean expression here. So while count is greater than 0 is our Boolean expression that is going to test that loop control variable and go ahead and as long as this evaluates to true, again, everything's going to keep going. All right. And then step 3, we need to change the loop variable, and we usually use one of our math operators to do that. So it's usually, plus equals something, plus plus, or minus equals something, or minus minus if we're just going down by 1. So in this case, we are going down by 1, and the programmer chose to use count minus equals 1. You could also just do count minus minus. That would do the same thing. But then, now count is down to 4. So it goes up and it checks our condition again. Count is still greater than 0. So we print our count again, and the count variable goes down to 3, and then it goes back to the top and checks your condition. This is still true, so we print our count again. Now we're printing 3. Our count variable goes down to 2. We test our condition. This is still true, so we print count, this time at 2. Count goes down to 1. We are still true on this one, and so we print 1. Count goes down to 0, and now we go up to here, and this evaluates to false. 0 is not greater than 0, so that evaluates to false. We leave our loop and then go down here and we print blast off. So that prints 5, 4, 3, 2, 1, blast off. There you go. After the loop breaks, anything below the curly braces will execute, and this is called halting the loop. So there you go. Those are the 3 main components to a loop. Now, one thing we need to watch out for are infinite loops. Infinite loops occur when a programmer forgets to change the counter. So for this one here, count is set to 5. While count is greater than 0, go ahead and print count, but we are not doing count minus minus, or it doesn't say count minus equals 1 or whatever. So this loop just prints 5 over and over and over again because that loop control variable never changes. All right. And then there's also what's called an off by 1 error. And this is another common example or common mistake that people make when they first start programming, especially programming in Java, where we have a little bit more control over how the loops work. Basically, what it means, an off by 1 error means we need to be careful with the Boolean condition when deciding whether or not to use less than or equal to, greater than or equal to. Sometimes we want the equal sign, sometimes we don't want it. So the following code is intended to print even numbers from 1 to 20, but it contains an error. How would you change it so that it works as intended? I'll invite you to go ahead and pause the video, see if you can work it out, and we'll go ahead and have a look at it in just a second. All right, so I'm going to assume you've paused the video. I'm going to assume that you've taken the time to work all of this out. So let's go ahead and work through this. Again, it's intended to print the even numbers from 1 to 20. So int num is equal to 1. And it says while num is less than 20, if num mod 2 is equal to 0, go ahead and print it. And then num plus plus, so we're going to go, we're going up, and that is it. So what's going to happen here is that this line, while num is less than 20, it makes it so that the code only prints 0 through 18, but it leaves out 20. And that's because, it'll print 0 because 0 mod 2 is 0. And then it won't print 1, but it'll print 2. But anyways, it's going to get all the way up to 18. And 18 mod 0 is 0, so it's going to go ahead or 18 mod 2 is 0, so it'll print 18. It'll go up to 19, and then it'll go up to 20. But then num is no longer less than 20, so you need to have less than or equal to in order to make that work. So change the condition to less than or equal to so that it actually prints the number 20, and the condition won't become false until num is equal to 21. So that's an example of an off by 1 error. And again, it basically just happens when you either forget to include the equal sign or when you include the equal sign when you actually should not. So it's always important to just basically read carefully what an algorithm is designed to do and then, see what it actually does. Now, code tracing loops. This is arguably the most important skill to develop in Unit 4. The ability to trace the code in a loop and understand what will happen. So looking at an example like this, this is the kind of code that we might see on our AP exam, and we would be expected to know what's going to print, what our result is going to print when we actually hit that line of code down here when we hit that print statement. So looking at this one, looking at this particular example, we'll go through our steps of code tracing. So again, step one is always to understand the question that's being asked. And again, what we're being asked is what's going to be the value of result when the program gets to the print statement, right? So we need to figure out this variable result. We need to trace it through this loop and figure out what it's going to be when it gets down here. All right, now step two is to look at how many variables that you need to keep track of and then create a trace table. So int n is a variable, int result is a variable. Here's n being used, so that's our basically n is our loop control variable. Then down here, int d equals this. So we've got three variables that we need to keep track of. So I'm going to make a column for n, a column for result, and a column for d. All right, and now what we need to do is trace the code line by line from top to bottom, and use our trace table to keep track of what's going on. So we'll go ahead and work through it. We've got int n equals 35. I'm going to pop 35 into my box for n. Int result equals 1. So I'm going to go ahead and put 1 in here for result. Now it says while n is greater than 0. Well, right now n is 35. That's definitely greater than 0. So that is true. So now int d is n mod 10. Well, n right now is 35. So n mod 10 is going to be 5. Now result is equal to result multiplied by d. Originally result was 1. 1 times 5 is 5. So now result is 5. And now n minus equals 10. We need to take our n and divide it by 10, which is going to bring us to 3. Because 35 divided by 10 would be 3.5. But because we're dealing entirely with integers, we're going to go ahead and truncate that 0.5. All right. Well, let's see. N is still greater than 0. So this is still true. So we need to go through and do all of this again. So n mod 10, 3 mod 10 is 3. A smaller number modded by a larger number is always the smaller number. And now result times equals d, so we need to take 5 and multiply it by 3. So it is now 15. And now n needs to be divided by 10. If you take 3 divided by 10, it's 0.3. But again, this is integer division, so we just lop off after the decimal point. N is now 0, and n is no longer greater than 0. So then we would go ahead and print result. So we would print 15. Finally, we've got a little bit more vocabulary here. What's called a sentinel value. A sentinel value is the value that stops a loop from executing in an input-controlled loop. So, for instance, excuse me, if you said enter a number to continue or -1 to stop, and then int answer equals input.next int, and then it says while answer is not equal to 1, go ahead and enter a number to continue or -1 to stop. And again, we're storing that answer, and we're just checking it over and over again. And then it says thanks for playing. So what's happening here is if I type in any number other than -1, it's going to invite me to enter another number, and I just basically keep doing that. But as soon as I type in -1, then that means this is going to evaluate to false, and this while loop is going to stop. And it's going to print thanks for playing. So -1 is what's called a sentinel value. It's the value, it's whatever I can type in to go ahead and make this while loop halt. All right, so the sentinel value is -1. There you go. With that, we also have a little bit more with user-controlled loops. They are very useful, but it's also important to know that they are not on your AP exam. So, to use a user-controlled loop, you have to use scanner to get input, and then repeat the loop until input equals a specific value, until you get that sentinel value. So again, you won't be tested on this on the exam, but for the majority of your programs that you're going to want to make in this class, you're going to want to use scanner. And, again, you're probably going to do a user-controlled loop. So we've got scanner being instantiated here. We've got the prompt, enter 1 for yes, 2 for no, or -1 to quit. And then again, we're storing whatever they type in. And actually this, and it says while answer, this should say int answer equals input next int. And then while the answer is not equal to 1, go ahead and do whatever this is supposed to do. So this would be an example of a user-controlled loop. All right, now we're getting to our lesson review. So again, iteration statements or loops change the flow of control by repeating a set of statements 0 or more times until a condition is met. Loops often have a loop control variable that is used in the Boolean condition of that loop. And remember the 3 steps of writing a loop. You have to initialize the loop variable, you've got to test the loop variable, and then you've got to change the loop variable. You have to give it its starting point, you have to give it its end point, and you have to make sure that you're moving it forward. In while loops, the Boolean expression is evaluated before each iteration of the loop body. When the expression evaluates to true, the loop body is executed. This continues until the Boolean expression evaluates to false, which signals to exit the loop. If the Boolean expression evaluates to false initially, then the loop body is not executed at all. An infinite loop is when the Boolean expression always evaluates to true so that the loop never ends. And then an off by 1 error occurs when the iteration statement loops 1 time too many or 1 time too few. All right, guys, well, that's it for today. Go ahead and leave a question or comment on our video, and I will see you in class.